Hello, everybody, and welcome to this episode of the Manufacturing Matters podcast, where we discuss the trends and technologies reshaping the manufacturing industry and beyond. My name is Jimmy Carroll. I'm the Vice President of Operations at Tech B2B Marketing. Today, I have the pleasure of being joined by Eric Utley, who's a 3D printing applications engineering manager at Protolabs. Eric, thanks so much for joining. Really appreciate it.
Yeah, thanks, Jimmy. This will be fun.
Of course, yeah. So, for those who don't know, I'd like to just start off by asking, tell us about Protolabs and what you guys do there.
Yeah, so Protolabs is a custom parts manufacturer. We have a core competency in digital manufacturing, which you can think of as just really highly automated manufacturing processes. We do 3D printing, sheet metal, CNC machining, injection molding, and we cater anything from like a single copy to a proto to end-use production of like tens of thousands, hundreds of thousands of parts.
Okay. Well, it's a very important topic, and it's a technology that's grown over the years, much like all the other technologies we discuss on the podcast. And one thing I thought was interesting that you said was that 3D printing is boring now, and that's a good thing, which is a nice provocative sort of statement or headline. What do you mean by that?
Yeah, so I mean, I should have clarified more. I'm specifically on the additive manufacturing side of the company, and I'm here at Raleigh, which is one of the largest 3D printing labs in the country. And I've been in the additive industry for 16 years, and something really good is that the industry is just rapidly evolving all the time. And we're really in unprecedented times of yeah, it's kind of boring now, but in the sense of, I would make little titanium printed lattices to take to our trade shows and show people, and they would be wowed at it. And, and I would tell people I work in the 3D printing industry, and, and it was borderline science fiction to people and kind of magical. And nowadays I tell people I work in 3D printing, and they go, "Oh yeah, my kid's got one of those," and it's old news for them. And like I said, that's kind of unprecedented for us in the industry. Is people kind of being in the know of what we do, and and on the face of it, yeah, it sounds bad. It's like, oh God, we're boring now, but really, it's a good thing, and it's by design. We've done our part for the last 20 years, educating the public about 3D printing. Explaining how the technology works, where it wins and excels, and we're a victim of our own success in that way of kind of spreading the word on the technology. And as I said, it's a good thing now, because there's a flip side of that historically 3D printing was kind of considered speculative or risky or fringe, and now it's a much more mainstream technology. I have colleagues who are specialists in CNC machining and injection molding, and it feels kind of like we've graduated to being a more traditional, considered industrial manufacturing process
Mhm.
for that. And so, yes, it's not as like kind of sexy or exciting or mysterious as it was before, but in turn, it's now considered much more realistically for things like end-use production, and is kind of a norm now in manufacturing to kind of consider additive as a possible avenue for making an end-use part that wasn't around before.
It's kind of funny. Like part of that description could almost be used for AI as well.
Oh, 100%.
It's like it's kind of a pipe dream, but now it's becoming sort of commonplace. And I'll ask you about AI a little bit later, but um, I do want to ask kind of a selfish question, because you mentioned, like, the technology was sort of foreign to people, and now it's commonplace, and you can buy pretty decent 3D printers from
Hmm.
Amazon for not that expensive. In fact, I I have three boys, and one of the gifts we got them for Christmas was a 3D printer, and people are amazed by it, and they're going, how does this work? And I try to explain to them, and my parents or my in-laws or whomever, and they're kind of like, I still don't get it, but that's really cool. uh, do you as somebody looking to get started in 3D printing just for fun, first of all, do you do that like as a hobbyist? And
Yeah.
how do you recommend people get started? Just jump right in?
Yeah, yeah. It's so I have a little Ender 3 at home, and and I kind of use car analogies here. So like I have what's called the Ender 3 at home, and it's kind of like the Honda Civic of desktop 3D printers. It's cheap, it's commonplace, but it's not very fast. It's not very fancy in the things it can do. And then lately you have really impressive ones coming from like Bamboo and Prusa, and they're kind of like the Lexus and BMWs of home. Again, they're a little more expensive, but they got the heated seats and the cruise control and the stuff like that,
Yeah.
and nice little features with them. And then yeah, I think it's a very approachable hobby and things to do. You need a little bit of technical aptitude for it. I was thinking like when I was in high school, my dad bought me a Volkswagen Beetle as something to take apart and work on and tinker with, and like cars have just gotten, that doesn't exist anymore, right? They're so much more sophisticated now,
Yeah.
and they're not designed to be easy to work on. So I feel like 3D printers have kind of taken that place of being something kind of accessible and tinkerable to work on, and the kind of the sky's the limit. You can take it and put it together, and it's akin to putting together IKEA furniture, and it's very doable as something like a middle schooler can tackle. There's a lot of online resources to kind of get up and running, and then like I said, the sky's the limit. You can go down deep rabbit holes of like coding your own your own G code and things like that, and you're not going to get too in over your head with one of the cheaper printers.
Yeah, and that's like I love a good analogy, and I appreciate that. We bought a Flash Forge 5, and I didn't want to go to the high end because my kids are, they're young. My
Yeah.
oldest is 10, and so like we do have a free version of a CAD program that they kind of tinker with a little bit, but then there's a bunch of libraries out there, and you can find those and print things and then put things together. But I love that it's like almost secretly a way to get kids into learning about CAD software and modeling and coding and things like that without them fully realizing it. Of course,
Right. Yeah. You sneak it in.
they're a little young for it, but it's anyway. It's super cool, and I was glad to find you guys, and I did want to ask about that. Um, and on the back to the manufacturing side of things, like I know kind of two questions in one. Like I know that for a while 3D printing, and I'm sure it still is, was used for things like rapid prototyping, but it's evolved past that a little bit, right? Like what are some of the
Yeah.
new and innovative ways that manufacturers now are using 3D printing technology?
Yeah, so it's still key to rapid prototyping, and we still do a lot of that. And I always tell people who are kind of unfamiliar with it, I'm like, anything you touch, basically that's manufactured, I can nearly guarantee you 3D printing was used at some point in the design process. Like it is just extremely ubiquitous in the research labs and the product development side of things. But absolutely, and you mentioned like AI undergoing this same sort of transformation, right?
Yeah.
And a lot of your listeners are probably familiar with it. It's called the Gartner curve. It's just like where a disruptive technology kind of enters, and there's all this hype, and then it kind of crashes out, and then it kind of rebounds.
Yep.
And 3D printing underwent that, and exactly to your point, it was back in the mid 2010s when you had, it was traditionally kind of rapid prototyping was really where it was used, and then you had big, Fortune 500 companies like GE and HP jumping into the ring and making 3D printers, and they were not interested in rapid prototyping. They were interested in using it for in-use production, and that was really when that shift started to happen, and you started to see 3D printing being used for in-use production. So, like for example, we print in metal using technology called direct metal laser sintering, and that's extremely popular in aerospace. Just extreme lightweighting of parts and consolidating of assemblies. And then we'll print in black nylon using a technology called multi-jet fusion
Hmm.
that can make really lightweight and strong plastic parts, and it prints very quickly. So it has some scalability that kind of encroaches on injection molding for that. But something that's really changed is, again, you go back 10, 15 years, and virtually everything that was printing was a prototype and would eventually be made some other way. So you look at a 3D printed part and you would say, this is eventually be injection molded, or this is eventually going to be 5-axis machined, or something like that. And more recently, we're seeing a lot of our customers actually design for 3D printing, and I think something to kind of take away from that is the sort of complexity, that any kind of application where complexity equates to value or usefulness is where 3D printing really thrives. So you get these kind of like Swiss Army knife type parts where, it's a piece of material, but it does a lot of things. A really interesting example is, something that used to be obscure and is now downright commonplace are what are called TPMS, or they're called triply periodic minimal surfaces. And so they're basically these very mathy repeating geometries, and they used to be extremely obscure, but they're getting more common in 3D printing. And one thing they'll do is be used in heat exchangers. So one property of them is that they separate. They have an A side and a B side essentially, and they can kind of keep volume separated. So you can pump, a coolant in one way, you can pump the heated material through another way, and the structure kind of like weaves it together without physically mixing the material. And so these are used in things like heat exchangers and condensers and applications like that, and they're just completely unmanufacturable without 3D printing. And so it's a great case again of that. Heat exchangers are a great thing where the more surface area it has, the more functional it is. And these structures are also very smooth and flowing, so it flows through really cleanly through there. And so it's just a great example of kind of leveraging the geometry capability of 3D printing to make something that you couldn't before.
Yeah, well, and then that's a great last line there, because and my eyes have really been open in the last, I'd say, 3 or so years to 3D printing, because before that, I thought of it as, whatever, small parts and prototyping and kind of that realm, right? But then I was visiting a company not too long ago, a year or so ago, and they had a 3D printed robot arm.
Yeah.
And so, like, they had other robots in the facility as well, like it was a cobot arm, and those
Mhm.
can be, whatever, tens of thousands of dollars, and their 3D printed robot was like $5,000 or $6,000. And I'm like, I had no idea that this was possible. I think part of that is because there's been a lot of innovations on, and you kind of touched on this, it's like the material side of things. Like, there's a lot more materials being used than ever before in 3D, which I didn't know, and maybe a lot of other people don't know about. What are some other ways that the expansion of the different types of materials that people are using are benefiting 3D printing tech and manufacturers?
Yeah, this has been a major sign of just, again, it's kind of like speaking to that maturation of the 3D printing industry that, back in rapid prototyping, you'll still see it on our website. We call it ABS-like, PC-like. And these were materials that were designed to mimic something that would eventually be injection molded, right? And then a challenge of 3D printing was always in that raw material. That at least the 3D printers we run, they don't use injection molding pellets. They don't use the blocks you would buy from CNC mills, and so they need to be processed in a certain way that can be fed into the printer. And that in turn limits the materials you can run. We may have customers who say, "Hey, can you 3D print in this specific metal alloy?" And it's like, there needs to be a vendor out there who atomizes that into a powder with a specific particle distribution and build parameters made around it. It's not as easy as just loading a block into a CNC mill or pellets into an injection molding press. But as the industry has grown, all these now there's a business case for these little niche materials, right? So when you're small, you only got vanilla and chocolate. But as the industry grows, now you have all these like niche specialty materials. So today we have things like flame retardant materials, ceramic filled materials that can handle high temperatures, ESD safe materials for sort of like electrical applications, biocompatible materials, silicone materials. So
Yeah.
there's and it's that move towards production too, that there's a stronger focus towards like application specific materials that are kind of targeting really kind of specific use cases and not general use cases. And so that's something that we'll go back and forth with our customers on, and kind of have our ear to the ground with our customers of, what sort of material requirements are coming, right? And again, that's kind of a evolving situation with additive of how do you kind of build up that material pipeline and kind of get materials that match to the application that's required for the part.
Hey everybody, I just want to take a quick second and thank our sponsor. Manufacturing Matters is sponsored by Tech B2B Marketing. They're a full-service public relations and marketing agency that focuses on technology companies, especially in the energy and automation markets. They provide full-service media relations, investor relations, employee relations, full end-to-end content development, videos, services, animation, full IT stack development from website integrating with ERP systems, CRM, marketing automation systems, and they bring a whole lot of knowledge and experience about technical markets since they've been servicing those markets for over 30 years. So if you have any questions, you want to learn more, go to techb2b.com. And now let's get back to the show.
Another question that's sort of selfish, but and it's not necessarily what you do, but I want to ask is, like, I have seen video, and these days you don't know what video is real and what's not, but how viable are 3D printed homes? Have you seen those?
Yeah.
Is it a realistic thing?
Yeah, well, that's a goal of mine, is to retire in one. I think I've been doing 3D printing for 20, almost 20 years now, and I'm like, all right, that'll be the capstone. Is I'm going to design my own 3D printed house and live in one. So let's kind of talk both sides, right? I think that's the best way to do it. So kind of some of the criticisms are, so the ones you typically see, they're like a gantry style system. They're basically building a really big FDM printer and filling it with concrete, and then they extrude material,
Yeah.
right? And then as we're talking about, like, you're talking about kids and desktop FDM printers. One thing I recommend exploring is called the continuous contour mode, or VASE mode, and it's actually very comparable to how houses are built. So that might be something kind of fun to explore if someone wants to design their own 3D printed house. Give continuous contour mode a run on your desktop printer. But some of the criticisms are, okay, we set up this gantry and we hit go, and then we come in the next day and all the walls are built, and it's like that's relatively a small fraction of the cost of the house. That all your cost goes into the windows, into the electricity, the electrical wiring, and things like that. And there's been some interesting ones with, like, low cost housing where they do it. But the ones but again, for me, it's like the design complexity, right? Like I want it to be like a little Hobbit, Lord of the Rings or Mushroom House or something, something really organic that you couldn't make otherwise. It's something we do with other manufacturing processes too, and something I always think of is, like, you almost want the design process to mimic the manufacturing process, right? So it's like if someone's designing a CNC part, a lot of it is like, this is what this cross section looks like, and then you cut out this way and you cut out that way. And then that sort of raises the question: how do you design parts for 3D printing? And it does almost make sense to have these kind of like organic grown shapes through that. So for me, you can get some really interesting designs with 3D printed houses, but I'm a little skeptical of it being like a cost saving way of doing it, unless you're just really just banging out a bunch of really small houses. There could be something there. But for me, it would really be about, getting away, again, it's like that design. It's like, hey, we got straight walls because we're using 2x4s to make this thing. But 3D printing allows you to get away from that and have things like curved walls and interesting arches. I was gonna do something around catenary curves and 3D printing, because there's a lot you can learn from, like, medieval architecture in designing for 3D printing, because they had a lot of the same problems of making these kind of self-supporting structures. So a lot of the sort of architecture you see from, like, medieval Islamic structures and medieval structures, they actually print really well. So it could be like a little bit of a resurgence for that. And I think that's the way it would go, is like you'd have some really creative designs that you could then 3D print a house out of.
Yeah, I mean, like, what's the fun in making a house-shaped house from a
Yeah,
3D printer? Like, if you develop a if you ever develop a Hobbit house, a viable 3D printed Hobbit house, put me on your wait list, please.
yeah, yeah. I'll let you know.
That's cool. You talked about AI earlier, and I'm wondering, you know, generative AI is such a hot topic now, and its
Yeah,
capabilities are growing so fast, like scary fast, in a good way. But I'm just picturing like I don't know how to code, for example. So is there a scenario where, if you have an AI agent, whether it's OpenClaw or whatever, could you use generative AI? Could I use generative AI to create a model, or in general, like how is AI and generative AI and all types of it boosting 3D printing efforts today?
yeah, yeah. So, like you said, this is evolving super fast. And so, what I'll do is I'll start it like 2 years ago and then rapidly get up to here, right? So, I wrote an article about this like in the first few months when ChatGPT came out. And what I did is I enjoy using Blender. It's open source and it's a 3D design software, but it's really for like animations and game assets. It's not a manufacturing design software necessarily, but it has a Python terminal inside of it. And then so right out the get go, right when LLMs became available, what I could do is go in there and say, write me a Python code for Blender to make a 3D CAD of a da 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 da, and then it would spit out a code snippet, copy and paste, hit enter, and it would create and it would create something in Blender. I was like, oh wow, this is awesome, right off the bat. But it had limitations, right? Like you could get simple things, and again, in hindsight, I didn't understand it at the time, but now if you think about it, like if you kind of word it in a codey way, then it would do it, but it couldn't really do like organic things, right? But it could do pretty impressive things. You could say like create a random distribution of posts that are within the size, and it could do that, but it couldn't. But you'd say like create a cat of a tree, and it wouldn't do that because there wasn't really any code out there for it to read
Hmm.
to make something like that. And then nowadays there's actually a lot of companies offering like text to CAD or really text to mesh, I think is the better way of saying it, of either text to mesh or image to mesh. And I play with that a lot, honestly. I'll create images in the AI generated software and then feed it into these and create things. I got little things on my desk. This is one I made like a year plus ago. So this is like when they were first available, and you can see it's like a little fighting robot thing, but it's really
Yeah.
kind of doughy and no features on it. And if you're in modeling, that's sort of useful because you can kind of drop it in and at least kind of get the silhouette and the shape of what you want. But nowadays, like this one's more recent, and you can see it's got a lot more detail on it.
Oh yeah.
And I imagine it's kind of done similar to how a human would design it, where it kind of roughs in and gets the general profile and the volumes, and then kind of comes back in and does detail. But they're at the mercy of their training data and what they have. So for these sorts of models that are going from image to mesh or text to mesh, like the primary use case is for people creating like video game assets, or people creating renderings. And so they're quite good at creating like little figures and fantasy weapons like bows and arrows and space guns. And they're quite good at like furniture, because you imagine you may want to fill that out, or like architects will have a lot of use of that because they'll design the building and then they want to make it more lived, and so they'll fill it in with furniture. I've noticed they've started to get like a phone stand. You can get a decent output on it, but it's not good at developing a surgical device. It's not good at developing a part for your car, because like that's really not in the training data.
Right.
Something I noticed was like they probably didn't have a paleontologist labeling the data because it was really bad at making specific dinosaurs. You would try to say make a stegosaurus and it would make some generic dinosaur, but it really didn't have the specificity to know what it was. So, but the fact we went from nothing to this in 2 years to where you can create these models is really impressive. And it's funny because like the hobbyists are really the ones who are benefiting from that the most right now, it feels like.
Yeah, I mean, we've seen that over the years with like it's like the proliferation of 3D imaging. Like 3D imaging used to be a kind of a cost prohibitive and larger technology, and I think like if you look at the Microsoft Kinect, remember the Kinect that came with Xbox?
Yeah,
Like
yep.
that was kind of revolutionary, and people were like taking that from their Xbox and finding ways to use it, and that kind of opened the door to like lower cost, more accessible 3D imaging. And it's interesting to see how hobbyists kind of drive innovation sometimes, or often, I guess.
Yeah, I was going to mention that, like people who wanted to kind of go further with their FDM printers is photogrammetry. Like you said, there's actually a lot of they're affordable, or they got a pretty generous like free trial period of you can get photogrammetry on your phone and can be scan things, and it takes a little bit of work to kind of get it printable, and also since this picture doesn't have any sense of scale, but
Yeah.
I've gotten pretty good results with that. Like one thing you can do is just go to like a thrift shop and buy some little chintzy statues and stuff and print and scan them just to kind of build up your skill set. But like that's very doable nowadays.
Oh, interesting. Well, that's some good input. I've got some homework here to
Yeah.
get the to start getting some more cool stuff out of the printer. We've been doing things like you said, like Zelda toys and
Yep.
ninja stars and glasses holders and whatever. But some pretty useful stuff. Um, what else? Like, do you have any? So you've seen a lot when it comes to the 3D printing industry. Do you have any predictions over the next couple of years? I know that's hard, but anything you expect to see?
Yeah. So I mean, we talked about kind of like the hobbyist side of AI, but like there's an opposite end too, where we've done a lot of like public collaborations with NASA of AI team, and like that's just a completely different approach where it's more of a constraint-based system. So they're kind of setting in things and saying that there has to be material here, putting up no zones where it says no material here, and just saying it has to be under this weight and at least this strong, and then they let the algorithm kind of tinker away with it, and then get an output. And those historically have, they're really compute heavy, and take, they all them mentioned some of the time it would take overnight, but then they recently did one where they did it within the span of a presentation. So it's getting faster, but and I spoke to it a bit earlier about just the complexity of the designs going up. But there's a trend in additive towards, and it's not necessarily AI design, but like a more broad term would be like computational design, where
Yep.
it's like these are very compute heavy, algorithmic based design processes that either iterate on the design or make the design from scratch. And that's a huge evolving subject in this industry, and like a really exciting one because they just go together like peanut butter and chocolate. These algorithms can design these really kind of complex parts, and then the digital manufacturing can in turn manufacture them.
Mm.
And depending on the application, you get a lot of value out of that. Again, it's like just extreme lightweighting for parts on satellites and rockets, and just extreme surface area for chemical reactors, and there's just a lot of like unexplored territory there. That's really exciting.
Very cool. I guess like one of my last questions for you would be for a company looking to get serious in 3D printing. What do you Where do you recommend they start?
Yeah, I mean, I recommend I mean, they can contact us and talk about their project. And it could be as anywhere in that journey, in the sense of, hey, we just want to kind of understand. I mean, we did that. I did that last week even. I had to give a tour to a company, and they didn't have any parts in front of them even at that point. They're just like trying to understand, where do we use additive? Where where is it when is it a better fit than these other technologies, and then we can also get to the point where there's a CAD file in front of us and kind of discuss it and kind of get down to the nuts and bolts of what are the material requirements, what are the quantities, what sort of pricing are we looking for that. But there's a wealth of information out there. Like I said, that's what's really changed is we used to really be kind of really educating our customers on the technology, and now they are much more educated as far as where the technology is, and it's penetrating further upstream, right? It used to be like, again, it would be like, all right, we're going to 3D print this and then jump to molding. But lately we really had customers who are like, we like this, it works, we just want more of it now. And then and we're looking at, we'll take it and critically look at it and say, how can we get more efficient with this part and make it viable for something like low volume production.
And I guess in those cases, if people do have, parts they could send you or CAD files, and it kind of makes it easy to be like, well, here's what we can do. Here are the different materials that we could use, and here's what it looks like. And then they have it in their hands, and they can say, yeah, this is what we need.
Yeah, our website's a great resource for that. So, again, with digital manufacturing, we provide instant quoting. So someone can upload a 3D CAD to the website, and depending on the material and the quantities you pick, you're going to get back an instant price and lead time for that. And then we have some automated design for manufacturability. So that's going to do things like look the file over for walls too thin to form or small gaps that will seal during the print. And then entire team is being customer-facing engineers who can kind of answer questions around, are there ways to improve this, or are there better options for this part, and really kind of drive towards solutions that way.
Well, that's very cool. And then that's actually the last question I was going to ask you is as we wrap up, like, where can people go to learn more? I think it's protolabs.com, right?
Yeah, protolabs.com is great, and you can reach out to us. People are welcome to email me. It's just going to be my name, just eric.utley@protolabs.com. But yeah, feel free to reach out to us, and we got a lot of information online, and got people happy to talk to you.
Awesome. Yeah. And if anybody has questions, we'd be happy to also pass them along to Eric. If you have, questions, comments, want to join the podcast, whatever, it's manufacturing-matters.com. And Eric, thanks so much for joining today. And I appreciate you letting me pick your brain both on the manufacturing side and the selfish personal side of 3D printing.
Yeah, that's cool. No problem. Yeah, no problem. Thanks, Jimmy.
Eric, thanks again.
Yep, thanks. Bye.